here, and welcome to the Metropolis. On today's video, we are going to be talking about the recent updates to NASA's Artemis mission to put humans back on the moon for the first time in over 50 years. Really cool stuff, and some of the first steps, the first out of 3 parts in the Artemis mission has already been underway. It launched a couple days ago, and we're going to be going over the other 2 parts of this mission and what they're essentially trying to accomplish with this next phase of space exploration. So let's dive into the article right now. So I have this fantastic article here from rmg.co.uk. I will link it in the description below, as we would with anything that we are going to be reviewing. And full props to them for the amazing infographics and getting all of the information accumulated in one spot. So let's just check it out. So NASA's Artemis mission aims to land the first woman and the first person of color on the moon, explore the lunar surface, and lay the groundwork for sending astronauts to Mars. Very, very cool stuff. So what is the Artemis program? The Artemis program is a series of ongoing space missions run by NASA. 3 Artemis missions are currently in progress. Artemis 1, an uncrewed test flight, which just launched successfully. Artemis 2, a crewed flight beyond the moon, which will take humans to the furthest they've ever been in space. Also very cool. A lot of new territory being covered. And Artemis 3, which will land the first female astronaut and the first astronaut of color on the moon, and involves spending a week performing scientific studies on the lunar surface, which is, again, just the idea of doing space science is cool in and of itself. I know these rockets, whether they're public, private, or combination of them, usually have payloads, companies bidding or purchasing their way to get these scientific experiments, out in 0G or, whatever the case may be, or, orbiting the Earth, seeing the effects of different things. And that in and of itself is cool, but the fact that now those experiments will be able to be done on the moon just opens up a lot of interesting things that we as a species are diving into. So Artemis 3 will be the U.S. Space Agency's first crewed moon landing since Apollo 17 in 1972, which is crazy. 50 years, basically. However, NASA's long-term goals are even more ambitious. Using the technology and research developed during the Artemis flights, NASA intends to launch a future crewed mission to Mars. This Moon to Mars plan involves building a new space station in lunar orbit and eventually a habitable moon base. How freaking cool is that? I know obviously these will start off as embassies and corporate / government owned things, but obviously it's opening up the doorways to some of the more interesting things coming down the pipeline. So the recent updates, as I mentioned, Artemis 1 updates following 4 canceled launch attempts due to engine issues and tropical storms, of which we have many of here in Florida. Artemis 1 successfully launched from Kennedy Space Center at 1:47 a.m. Eastern Time on Wednesday the 16th of November. So about 3 days ago, with me recording this now on the 19th of November 2022. So what is Artemis 1? Formerly called Exploration Mission 1, this uncrewed mission is an extensive test of the Space Launch System, or SLS, and the Orion module. The Space Launch System is the most powerful rocket ever built, generating 8.8 million pounds of thrust on liftoff, making it 1.3 million pounds more powerful than the Saturn V rocket used in the Apollo missions. Pretty crazy. Artemis 1's journey will take it 450,000 kilometers to the moon, where it will orbit 400 kilometers above the lunar surface before continuing approximately 64,373 kilometers beyond into deep space. After a mission length of 25.5 days, the module will splash down in the Pacific Ocean near California on 11 December. It's a nice little wrap up for the spacefaring that this uncrewed machine will do. And here we have this amazing graphic, which they have on this website, which, like I said, I will link to for each of the 3 missions, that essentially plots the whole flight path and trajectory. It's really cool to see all the little steps, places where, it disconnects here on number 7, and then to the eventual splashdown here, 17. That's adorable. They have the parachutes in the photo, but this is all just really fascinating stuff. Just the physics of it and all of the logistics of it. Very, very cool. And obviously the scaffolding that they're doing, wherein they're first doing the uncrewed mission, and then they're doing the crewed mission, and then they're doing the crewed mission, which will land on the moon. Obviously, very logical. They wanted to make sure things are tested at multiple points along the way with these 3 different missions. So very cool stuff, and I highly recommend checking out this graphic if you'd like to nerd out about the science of things, and the article in general. On board are a range of science and technology experiments that will take place in deep space. These are designed to expand lunar knowledge, make further technological developments, and shed light on deep space radiation, which sounds like it would be a pretty important thing to know about. I know that we are protected here on this planet by, the atmosphere that we currently have left, despite, the causes that we've had on it. It is still way nicer than just being out there as far as the physiological effects. So I'm excited for us to learn more about deep space radiation and ways to combat it, or at least negate its effects. Also on board are 3 mannequins wearing first-generation Orion Crew Survival System spacesuit, which the real astronauts will wear on Artemis 2 and 3. Sensors have been placed all over the mannequins to provide data on what human crew members may experience in flight. So very cool to have these mannequins or mannequins right here wearing the exact same thing that the astronauts will be wearing, so that makes sense. They're going to get data as far as how did these suits fare, what damage was done, what is the breakdown that occurs to these suits when they go into space. So that's, a lot of peace of mind for the astronauts on flights 2 and 3. So it was kind of clever. I read this before, how they tied this all together. I do appreciate the naming methodology here. Why the program is called Artemis is because Artemis is the mythological Greek goddess of the moon and twin sister of Apollo, which is the one we went to, which was the name of the mission that took us to the moon in the first place. The link with the mission, which first launched humans to the moon over 50 years ago, therefore is clear. The crewed spacecraft, meanwhile, is called Orion. Orion is one of the most recognizable constellations in the sky, while in classic mythology, Orion is the hunting companion of Artemis. So nice little bow tied to all that. And here we have some nice Artemis mission facts. We see that the duration so far has been from 2017 to the present, so it's been ongoing for a while. Obviously, there was planning that went into this, getting it to the point of launch, just now launching the first of 3 of these missions. The first one being launched, as I said, on the 16th in the morning. The second one is going to be no earlier than 2024, with the third one projected for 2025. So why is NASA going back to the moon? Other than the fact that obviously that's one of the next steps, and it's just a pretty amazing thing for us as a species to be endeavoring to do. They go on to say NASA is not simply aiming to repeat the feats of the Apollo missions with Artemis, but rather go to the moon and stay there. That means investigating the possibility of establishing bases both in lunar orbit and on the moon's surface. Although the primary goal for now still involves returning humans to the moon by the middle of the decade. So that lines up with their 2025 projection. Just a very nice milestone for us to be at. It's kind of crazy. You can think of the different geopolitical reasons, the public and private reasons, the various things that go into launching rockets that cost X amount versus Y amount, etc. But 50 years and not being back on the moon, especially for a planet that does go into space pretty regularly, even before these private space programs became such a thing, it's pretty interesting to think that we have not actually been back to the moon until now, until this mission. So I think it's going to open up this amazing new horizon, much like deep sea exploration, much like visiting these areas that, maybe we've been to once or twice, but now we really have the technology and the time to really dig in and learn as much as we can as we, spread our reach out into the universe. So some of the mission objectives include an array of things such as equality. A chief aim for NASA is to land the first woman and first person of color on the lunar surface. Technology. From rockets to spacesuits, the technologies currently being developed are designed to pave the way for future deep space missions. Awesome. Partnerships. The Artemis program is one of NASA's first large-scale collaborations with commercial companies such as SpaceX and Boeing, which is pretty cool. Long-term presence, where the Apollo 17 crew spent 3 days, just 3 days on the lunar surface, Artemis aims to establish a base to extend trips to weeks and possibly months. Also, just really, really cool stuff. Knowledge, as more is known about the moon compared with 50 years ago, and technologies have greatly advanced, NASA claims that this is the next in a series of missions will be able to retrieve samples more strategically than during the Apollo era, which is also very logical. 50 years ago, I mean, I'm recording this on devices that probably had power that were comparable to some of the computing hardware that went into some of those original missions, including the Apollo mission, which sent humans to space and the moon. It's pretty wild to think of the range of things that they'll be able to do now with the most recent technology that we have. They go on talking about some of the delays, and they have this another great graphic here, which is just stuff like this is so cool to me, especially as somebody who is a big fan of science fiction and, you know, futuristic looks on how we will do things. But even with the things we see today, which can be I think really easy to look over as just these big, I do it myself, these big cylindrical, all right, it's a rocket, whatever, it shoots you up there, you come back down, Bob's your uncle, that's it. But here they actually show all of the separate, independent but interdependent aspects of the Orion and all of the segments that go into it, from the spacecraft adapter, service module, crew module, launch abort system, etc. I'm not going to pretend to be a rocket engineer and know what these pertain to, but it is very cool to see the mechanistic side of it and the logistics of how these all tie together, because every single one of these serves a purpose. I don't think there's a redundancy that I can spot here. So very cool stuff, and once again, really cool infographics from this website. Goes on to talk about some of the particulars. You can read that if you like, about the lunar gateway, the moon landing module, etc., the SLS, space launch system, the various particulars that will go into it. What I find really interesting is when we get into phase 2 and 3 of the Artemis mission, with the second one having to do with pioneering crewed spaceflight for the Artemis program, taking humans further than they've ever been in space. So they're going to go behind the moon, and they're going to see the dark side of the moon, because for spooky, and I say with air quotes, even though I do think it's a little, I mean, I know there's a scientific reason for it. I don't know the scientific reason for it, but it is interesting that there's a side of the moon that we never see. So Artemis 2 will actually go behind that. It will see it. Maybe they'll tell us what they actually see. Maybe they won't. Who knows? Could be anything back there. But that technically is going to put them further than any human being, Homo sapien, has been. So very, very cool stuff. After being launched into space by the SLS rocket, the 4-person crew will fly the Orion module 7,402 kilometers beyond the far side of the moon, complete a lunar flyby, and return to Earth. The mission will take between 8 to 10 days and collect valuable flight test data. So we see, again, the scaffolding, learning more each time. The first one, which is out there now in space, an unmanned crew, an unmanned flight, and the second one being the manned flight, which will not actually land, but will gather important data for the third part of this. Another one of these great infographics, again showing each step of the equation here, from launch to jettisoning the rocket boosters, etc. We have another separation sequence here, and just very cool stuff to see how meticulous this has been planned, and the way, I don't want to say you guarantee success, but the way that you scientifically increase the odds of success by methodically having a very tested approach. Finally, Artemis 3, the third mission to the moon, is set to be the first moon landing since Apollo 17 in 1972. Building on the Artemis 2 mission, 4 astronauts aboard the Orion module will dock with the lunar gateway and remain in space for 30 days. The human landing system will then take 2 astronauts down to the moon's south pole, a region previously unvisited by humans. The astronauts are expected to spend a week exploring the surface and perform a variety of scientific studies, including sampling the water ice first detected on the moon in 1971, which is very cool. I don't know what the ramifications of terraforming that moon would be, but the fact that there is water, the fact that there's ice/water there is, obviously lends itself to some optimism. And here we have the third mission trajectory, and it looks like a bunch of interesting stuff is happening here. I'm not even sure. Perhaps this has to do, let's see, let's find number 16 here. 16 crew. Oh, so 16 pertains to like getting back there, I suppose. Orion undocks, performs orbit departure burn. Okay. So perhaps, I mean, again, I'm not, my rocket science knowledge is non-existent. I'm definitely a plebeian in this, but I assume perhaps landing has something to do with this big looped trajectory that they have to make. Not really sure. It looks like they have an alternative angle too for some of the things. So very cool stuff. This is the one where they're actually going to be landing on it and spending a full month on the moon, which is just, we should all feel great about, because it's growth for all of us. Especially, I like the fact that it is not privately funded. It is a public-private partnership, which is great. It goes on to talk about some of the future missions, Artemis 4, 5, 6, and more. NASA primarily focus their attentions on 1, 2, 3, but are also looking ahead to future projects and have already awarded contracts for booster rockets and Artemis up to 13. Well, that's pretty amazing. So they got a lot of plans. These different companies are competing, and it's very cool stuff. Yeah, so I thought this was really cool. I had heard about it. I live in Florida, so I see and hear about the rockets being launched all the time. But, for the most part, it's this being tested or that being tested, or just standard payloads from different companies or public organizations that are doing their various tests and whatnot. But for something like this to be the first time that we're going to be going back to a celestial body, which the moon is, our celestial roommate, essentially, in over 50 years, is pretty amazing. And just to give a little bit more context, this photo, which, if you know the actual person who did this, I will happily put their credits in the description. But essentially, the mind-blowing thing is to think that between 1903 and 1969, the amount of progress we made was akin to first human flights with the Wright brothers and first touchdown on the moon with the Apollo mission. Now, 50 years later, because we kind of took time away from going to the moon, developed other technologies, had different occurrences, but nonetheless technological evolution, we're going back, and I'm hopeful to see a similar level of just insane progress. It's crazy to think the amount that happened between 1903 and 1969 as far as human beings traversing the cosmos. So I'm very, very excited about this new phase of space exploration. But what do you think? Are you excited for this? Are you looking forward to other things? Are you just impatient for us to get to Mars already? Obviously, this will have big ramifications for that. Let me know your opinions, your thoughts in the comments below, and I'll talk to you next time. Cheers. Bye.